All right, next up, we're going to learn about potentials and kind of what that means. So remember, some reactions are spontaneous, some aren't. And all of this has to do with Gibbs free energy, right? Delta G, this energy difference between the two. Well, in electrochemistry, we generally don't talk about things in terms of delta G. We talk about this energy difference as a potential or a voltage. So I'm sure most of you have heard of voltage. So to understand voltage, I like the water analogy. So on the left side, we'll talk about water. On the right side, we'll talk about electricity, potential, and that kind of stuff. So imagine you have this kind of scenario. What you have here is a waterfall. So you've got water flowing down, and then there you go, right? This is water, right? And water is going to flow down the waterfall, obviously. And so we can think about this height difference as something that is important. So if you kind of were sitting under this waterfall, depending on how tall it is, you would experience more force for a taller waterfall and less force for a less tall waterfall, assuming the water didn't kind of reach terminal velocity, right? So there's a height difference, an energy difference between the high up state and the low down state. Well, electrons flow in a very analogous scenario, right? So they flow down this hill. In this case, we're talking about electrons. And what we call this kind of height difference, it's an energy difference, and that's what we call the potential difference. So if something's 1.5 volts, that means that the height between these two states is 1.5 volts. And 1 volt is equal to 1 joule per 1 coulomb. Coulomb is a unit of charge. Right, so you can tell it's energy joules per charge, joules per charge. And so think about on the water side, you could measure the flow of water or the rate of flow, maybe in something like gallons per minute. You can do the same thing in terms of electricity, except here we're talking about amperes or amps. 1 amp is equal to 1 coulomb, which again is a unit of charge, over 1 second, right? So same thing as the flow. And so this potential difference, this difference in energy per charge is what can do work. And the ability to do work is what's called as an electromotive force, an EMF, right? And so when you're combining a cell, what you're talking about is how much voltage is my cell going to be able to put out? Well, it's the height difference between your starting and ending point. And so this is what's known as cell potential, or E cell. In this case, E doesn't stand for, it stands for your cell potential, not technically energy. Very related, but not exactly the same thing.